Good day, everyone. Today we have this topic on the board. The topic is called circular motion. Now, what is circular motion? Circular motion is the movement of an object or a body with constant speed around a circular path. Please take note of the words. Circular motion, it is the movement of an object or a body with constant speed around a circular path. Now, because the speed is constant and the body is changing direction, so therefore velocity is changing. I'll say it one more time. Circular motion, it is the movement of a body or an object with constant speed around a circular path. And because the direction is changing, then the velocity is changing. So it means that in circular motion, speed is constant, velocity is changing. And because velocity is changing, acceleration is also changing. Please take note. Circular motion is the movement of an object around a circular path with constant speed and varying velocity and acceleration. That is just it. Now, when a body, there are two forces that keeps an object or a body in circular path or in circular motion. And those forces are what we call the inward force, which is also called the centripetal force, and the outward force, which is also called the centrifugal force. There are two forces that keeps an object around the circular path. For example, let's take an example of objects around the circular path. For example, the movement of the tires of a car, the movement of a ceiling fan, that is circular motion. The movement of the earth around the sun, these are circular motion. These are examples of circular motion, right? Now, the two forces that keeps these objects in circular motion are the inward force, which is also called the centripetal force, and the outward force, which is also called the centrifugal force. Now, what is the centripetal force? Now, let's take an example. We said it is the inward force, which is the force that keeps that object inside the cycle. For example, let's say you have maybe a bike, all right? A bike is going through, maybe you are in a bike now, for example, you are in a bike, and the bike is to pass through a roundabout. Okay? Now, when that bike is turning, when it is turning to go through the roundabout, there is a force that is keeping that bike inside that cycle. You will not fall off. It is going. It is turning like this, and you will not fall off. That is the inward force that is holding that bike. That's an example of what I want to explain, the centripetal force. Okay? The force that keeps that body, the inward force that keeps that body in that cycle. When in a bike that is going around a roundabout, if the bike is bending, you are bending. It is bending, you are bending. You people will not fall off. Sometimes you look as if you want to fall inside that cycle. No, you keep up bending and bending till you go through that roundabout. There's an inward force that is holding you. As an example. Now, how about the centrifugal force? Centrifugal force is also called the outward force. Let's take an example of if you are in a car and you are the passenger, you are seated at the passenger seat in the front of the car. And if the driver is to turn left, you will go right. Do you see now? If the driver is turning like this, you are going like this. Why? That is centrifugal force. The outward force. It is pulling you out. So this an example of centrifugal force is a car going around the bend. If a car is going around the bend, it's different from when a bike is going around the bend. If a bike is going around the bend, you'll be following the bike and be turning like this. But if a car is going around the bend, if the car is turning like this, you'll be going like this. If the car is turning to the left, you move to the right. That is centrifugal force. Now, in the inward force, which is centripetal force, we know that force is equal to mass and acceleration. That's the formula for force. Now, there's what we call the centripetal constant. This centripetal constant, this is it. A, which is acceleration, is equal to v squared all over r. This R here stands for radius of the cycle. This V stands for velocity. Alright, A is equal to V squared over R. This is a centripetal constant. Now, because F is equal to ma, which is mass times acceleration, we have to replace this A here with this value because A is equal to this. So we can just replace A with this value. So F is equal to m still remains here. But instead of putting this A now, we have this value here. We have m is here. Then we replace A with V squared over R. This is it. Now this is the formula we use when we are asked to calculate for the centripetal force, which is the inward force. Please take note. We are going to solve questions on this. We are going to solve so many questions on circular motion. But we're going to now let's take a look at this past question on the board. Question number 1. It says a car of mass 1500 kg goes around a circular curve of radius 50 meter at a speed of 40 meter per second. The magnitude of the centripetal force is dash. A 1.2 times 10 raised to the power of 2 Newton. B 1.2 times 10 raised to the power of 3 Newton. C 4.8 times 10 raised to the power of 3 Newton. D 4.8 times 10 raised to the power of 4 Newton. Look at this question. What did they ask us to calculate for? They say the magnitude of the centripetal force. So we asked to calculate for the centripetal force, the value of the centripetal force. Now in the question we're giving mass to be 1500 kg. We're giving radius, a radius of 50 meter. We're giving velocity or speed to be 40 meter. Then we're giving force. Okay, we're asked to calculate for force. Simple. I've already showed us the formula. How we derive the formula? F is equal to mv square over r. We're asked to calculate for F. So we don't know what F is. F is equal to what is M? 1500 times V. What's V? 40. 40. Can just put it square. All over R. R is what? 50. Now F is equal to 1500 times 40 times 40. 40 times 40 should be 1600. I think so. 40 times 40. Yes, 1600 all over 50. Now we then multiply. F is equal to 1005 times 1006. Okay, divided by 50. We have 48,000. When you multiply these two divided by 50, you get 48,000. Now, if you look at the options, we are giving the options in standard form. So we have to convert this to standard form. F is equal to 1, 2, 3, 4. So the answer is 4.8 times 10 raised to the power of 4 Newton, which makes option D to be the correct answer. Please just when you are seeing it, just drop a like, drop your comments. If you need me to make improvements, please drop it in the comment section. I'm open to that. And please follow my YouTube channel that will be posted in the comment section. Now we have this concept of angular speed and velocity on the board. We know that velocity is the rate of change of displacement with time. Velocity is the rate of change of displacement with time, which makes the formula for velocity is normal velocity, or linear velocity is displacement, which is over time. Right? This is the formula. But in this case, we're talking about angular velocity. Right? So angular velocity, it is still the rate of change of the angle over time. That is the same thing. This stands for angular velocity is equal to theta, which is the angle all over time. We say this we can call it W now. It stands for angular velocity, which is measured in rad per second. Normal velocity is measured in meter per second. This is measured in rad per second. Alright? And this angle, this T here stands for theta, is the angle, which is measured in radian. This T here stands for time. Alright? Now, there's a relationship that exists between linear and angular velocity. This is linear velocity, this is angular velocity. The relationship that exists is V, which is linear velocity, is equal to radius, which is R, times angular velocity, which is W. V is equal to radius times W. Now, in cases where in the question we are giving frequency, alright? When we are giving frequency, I have to calculate for the angular velocity, we use this formula. Note that W, which is angular velocity, is equal to 2 pi f. This should not bother you at all. When we start solving questions, you see that it is very easy. We have question number 2 on the board. It says a particle of mass 10 raised to the power minus 2 kg is fixed to a dip of a fan blade, which rotates with angular velocity of 10 rad per second. If the radius of the blade is 0.2 meters, the centripetal force is dash. A 2 Newton, B 20 Newton, C 200 Newton, D 400 Newton. Now if you look at this question very well, they give us angular velocity. Okay, they give us mass, which is 10 raised to the power minus 2 kg. They give us angular velocity of 100 rad per second. They give us radius of 0.2 meters. They ask us to calculate for the force, the centripetal force. And we know that the formula is F is equal to mv squared over r. But in this question, we are not giving V. We are giving M, yes. We are giving R, yes. But we are not giving V. But we are giving angular velocity. I told us the relationship between linear velocity and angular velocity. I told us that linear velocity is equal to angular velocity times R. Now, linear velocity is equal to, what is angular velocity? 100. 100 times, what is R? 0.2. V is equal to 100 times 0.2 is 20 meter per second. Alright? Now, we then use this formula because we've already gotten V to solve. Then we have F is equal to mv squared over R. F is equal to, what is M? 10 raised to the power minus 2 times, what is V? V is 20. 20 squared, please take note of that. All over R. R is 0.2. Now, let's solve further here. We have 10 raised to the power minus 2 times 20 squared is 20 times 20. And 20 times 20 is 400, yes. All over 0.2. So we have 10 raised to the power of minus 2 times 400 divided by 0.2, 20. So F is equal to 20 Newton. And 20 Newton is option B. Please, when you are giving a question like this, you have to know the relationship between linear velocity and angular velocity, which is, this is the relationship. If you can just find the relationship and get this linear velocity, then you are good to go. Please drop your comments, share, like, follow my YouTube channel that will post in the comment section, and please just react to the video. Let's go the page together. Thank you very much. Now let's take a good look at question number 3. It says a particle moves in a circular orbit of radius 0.02 meters. If the speed of the particle is 0.88 meters per second, calculate the frequency in cycles per second. A 2.0, B 7.0, C 8.8, D 14.0, E 17.6. Now they said we should calculate for the frequency in cycles per second. Now we said the particle moves in radius 0.02 meters. So they give us radius to be 0.02 meters. Then we have the velocity to be 0.88 meter per second, and we're asked to calculate for the frequency. Alright? Now we know that the only formula that connects frequency in circular motion is this formula. Angular velocity is equal to 2 pi f. Now, but in this question, we're not giving angular velocity, but we're giving linear velocity. Now, see, we're going to calculate for, first of all, angular velocity before we calculate for the frequency. And we know that the relationship between both of them is V is equal to angular velocity times radius. So, V, we're already giving V to be 0.88 is equal to, we don't know what angular velocity is, times R. R is 0.02. Then 0.88 is equal to 0.02 W. If you multiply both of them, then we divide both sides by 0.02. 0.02. This will cancel out. Then the angular velocity is equal to 0.88 divided by 0.02. we have 44, which is 44 rads per second. Alright, 44 rads per second. Then we will now be able to calculate for the frequency. Angular velocity is equal to 2 by f. Angular velocity, which is 44, is equal to 2 times, we know pi to be 22 all over 7, or 3.142. Let's use 3.142 times f. Now 3.142 times 2, that is 2 times 3.142, gives us, which is 44 here, is equal to 6.284 f. Alright, 6.284 f. Now we have to divide both sides by 6.284, right? So we'll solve that here. Then if we are dividing, we have here 44 divided by 6.284. We are dividing both sides because we want to calculate for f, right? Is equal to 6.284 f divided by 6.284. This will cancel out. So therefore, f is equal to 44 divided by 6.284. 7 what? Frequency is measured in hertz. 7 hertz. This is your final answer. 7 hertz. And which is 7.0, which is option B. You see how we solved it? You have to understand how to relate these formulas. The relationship between angular velocity and linear velocity, that's what we used first of all to calculate for the angular velocity, because we're not given in the question. And we need angular velocity to find frequency. Then we solve for angular velocity. For angular velocity, then we solve for the frequency. Please drop your comments. Please, if you don't understand, you can ask me questions in the comment section. And if you also have problems in physics, you can drop the question in the comment section. Let's attempt to do it together. Follow my YouTube, subscribe to my YouTube channel that we posted in the comment section. Thank you very much.